Hello dear students. Now from this video onwards, we will see implementation of the linear queue using array. In the previous video, we started the topic linear queue using array. And we got introduced to how you use array and two counters front and rear to create a linear queue. Now from this video onwards, we will see implementation of the linear queue using array. How do you declare a queue that can be created using an array has been shown here. You declare a structure called queue, and as you know, structure is collection of many things. Then we have declared one array of fixed size. You can see size is a constant over here, and the value of size is 5. So size of this array is 5, and it is an integer array, and two integer counters, front and rear. So you can think of a box. This is a structure which has an array of size 5. So indexes are 0 to 4 and two counters, front and rear. So simple. This is the way how you declare a structure to create a queue. Now, two major operations, as you all know on the queue, is insert and delete. And it is, remember, it's a FIFO data structure, first in, first out. So how do you implement insert and delete? Before that, let's see two very important lines in main. Now this line declares a variable called queue of type queue. So this is a variable that will contain array, front and rear, because queue structure contains array, front and rear. So in the memory, queue is a big box. This is the structure variable which contains array of size 5 and two counters, front and rear. Now just observe, we have declared a variable called queue, and this is going to act as first in, first out data structure. But what if you want one more queue in the same program? No problem. You can declare one more variable separating with comma, and maybe you can say new variable is W. So how do you describe W? W is also a queue, isn't it? So in the memory, there will be one more box W, which is a structure, and this will also contain array, front and rear. This is the way you can declare as many queues as you need. And each of them, Q or W, is of type structure queue. Now this queue will store its own values and updating front and rear. And this QW will store its own values. Maybe we are storing 100, 200 in this, some other values, and it will update its own front and rear. So it's so easy to create as many queues as you want. But in this example, in this program, we have built only one queue, as we just want to demonstrate what are the main operations on the queue. So we are handling only one queue. So coming back to the picture, this queue is a structure variable which has array of size 5, 0 to 4 and two counters, front, correct, and rear. Now observe, this queue is empty. What do you say? Absolutely no values have been stored in this queue. In such situation, front and rear must be -1. By making them -1, what we are telling is that even 0th place is not filled. So front and rear are even before the 0th place. They are -1. That has been done on the next line. Q dot front and Q dot rear both have been made -1. And then we write a menu driven program using do while loop and switch statement. And you can see that we have options like insert, delete, display, destroy, exit. And we ask the user to enter the choice. Let us say that the user enters choice as 1. In that case 1 becomes true. And case 1 is for inserting a new value in the queue. So what we will do is we'll ask the user to enter the value that the user wants to insert. Let's say that user gives the value as let's say 10. So we are interested in inserting a new value 10 in our empty queue. Remember, the queue is empty at the moment because front and rear are -1. And here is the call to insert. As usual, I think this is in the series of stacks and queues. This is the fifth program that we are learning. We have learned stack using linked list, stack using array we have learned. Then we have learned linear queue using linked list, circular queue using linked list. We are quite used to passing the address of the queue, isn't it, to the insert function, and then we are passing the value that we want to insert. The value we want to insert is x, that is 10. Okay, let's come to insert function. Here is the insert function. Obviously we are passing address of the queue, so address of the queue will go in the parameter p, isn't it? Let's see. Here is the address of the queue getting passed and it gets copied in p. So we have a queue which is a structure variable, and it has array of fixed size 0 to 4 and two counters, front and rear. And remember, both are -1. We did that in main, isn't it? Indexes as I am drawing 0 to 4. So we are interested in inserting 10 in this queue, and p is a pointer which stores address of the queue. So here is the pointer p which points to queue because it stores address of this whole box. Now I have a look at this insert function. First things first, we check for overflow. Now when is the queue overflown? Is when rear is equal to size -1. Remember, size is 5, defined in hash define constant. 5 minus 1 is 4. So we ask, is p arrow rear equal to 4? Now watch that, p arrow rear, this rear stored in this queue is -1. So this isn't true, isn't it? But if this condition was true, that means rear happened to be 4 and size -1 is also 4, then program will announce overflow. We will shortly see that. So we are in the else. Everybody agrees that. Here is the else part. This is the end of else. So in the else, first thing is we increase rear. Rear, which is -1, look at this, I am updating it to 0. It has got increased by 1. Now what does that mean is we are ready to insert that new value 10. We want to insert 10, and we have decided that we will insert that 10 at place rear of the array. Rear is right now 0. So we will insert the new value 10 at place 0 of the array. So rear counter decides at which position are we going to insert the new value. Here comes the next line. X, which is 10, should go in place 0. Observe, p arrow rear is 0 of the array. So this 0th location stores 10. Now comes the very interesting part of linear queue. You watch, we are successful in inserting that new value, isn't it? 10 has already gone in the array, but we ask a question. So this is a nested if. This if has been written inside the else of another if. We ask, is front equal to -1 right now? Oh yes, it is -1. Observe that front equal to -1 and rear is 0 right now. As this is true, what we know is this insertion that we are doing is the first insertion. Rather, before this, the queue was empty. That means front is surely -1. Then we forcibly make front as 0. So front, here I am updating in the box, front which is -1 also becomes 0. Don't you agree that front and rear both should be 0 because there is only one person standing in the queue, which is 10, and 10 is the frontmost and 10 is the rearmost. Just have a look at this condition again. If front equal to -1, then make front equal to 0. Watch that this condition, if front equal to -1, will become true only once. because during the next insertion, when we insert 20, let's say, then P arrow front won't be minus 1 anymore because we have made front equal to 0, and it will stay 0 till we delete something. That's it. After this if, this is the end of else and end of the function. Let's try to insert a few more values and keep reading this code of insert and try to understand how the insertion is done. So for that, I'll draw the queue again. The queue here that we have is A. The array A is having only one element, isn't it? 10, placed at 0. And other elements of this array are right now not storing any values. We have front equal to 0 and we have rear equal to 0. Now imagine that we want to insert 20 in this. So we have called insert for the second time from main, and obviously we pass address of the queue. So P is a pointer which points to queue. Now look at the code. Is P arrow rear equal to size minus 1, that is 5 minus 1? P arrow rear at the moment is 0. So it's not yet overflown, and we come to else and execute this else. Tell me the summary. We want 20 to go in the queue, correct? And what is the place for 20? Of course, 20 will stand behind 10. That means in the else, we are simply increasing rear by 1. Watch that, rear which is 0 is now 1. So rear is 1 means that the new value 20 will now go and stand at first place of the array. So array, next line you see, array first place, because P arrow rear is 1 should become 20. Hence 20 is stored at the specified place shown. And now check that last if, which is nested if written in the else. This if which I am underlining, this if is surely false. Front is not minus 1. In fact, front is 0. So there won't be any change made to the front counter, and that ends the insert function. You just tell me, aren't two values there in the queue, 10 and 20? And watch, front is 0 has to be because 10 is the frontmost. This person went in first in the queue, and rear is 1 has to be because 20 went last in the queue. At the moment, the queue is 10, 20. What if we insert some more values? Now let's not read the code. We have become comfortable with the code now. But what if this is the queue, and watch that the queue has these values stored: 10, 20, 30, 40, 50. That means we have called this insert function 5 times. So front is going to be 0, isn't it? And rear is going to be 4. Check that, frontmost person 10, rearmost person 50, standing at 4th place. And now suppose we try to insert 60, passing the address of the queue, correct? So P points to this queue. But watch that, 60 can't be stored in the queue because there is no room in the array. All the elements of the array which was of fixed size has been filled. So this if, the very first if, like a gate, is going to restrict us going to the else, because P arrow rear is 4, as you see. Yes, P arrow rear is 4, and size minus 1 is 5 minus 1, which is 4. So this condition is true. It means even the final location of the array is storing some value. As this condition is true, our program will shout queue overflow and not go to else. So insertion of 60 is not allowed. This is overflow error. Now, however number of times you call insert from main, you are going to get queue overflow. This is the summary of the insert function. Remember, insert always increases rear counter by 1 and puts the new value at rear place. In the next video, I will tell you how to delete values from a linear queue. And we are heading towards a very interesting discussion which will tell us disadvantage of linear queue. So see you in the next video. Thank you very much.